Next problem is given the function is from minus 15 to 15 closed interval to a set of real numbers defined by this function. This is a greatest integer function and sin x plus cos x. Next, f is a even function is given. What is even function property? F of x equal to f of minus x. Okay, that is f of x minus f of minus x equal to 0. So your function is f of x is given, you find f of minus x. F of minus x equal to what is the value? When you substitute x is minus x, you are get again same x square you get, isn't it? So x square by a into sine of minus x is minus sin x. Next plus cos of minus x is cos x is a even function. So cos of minus x is cos x. So this is equal to minus x square by a greatest integer sin x plus cos x. Okay. So next you add these two, you substitute in this relation 1. So adding the function, that is you subtracting or you are subtracting this function f of x minus f of x, what do you get? So say this becomes minus become plus and this is minus, cos x term will cancelled. So finally your function f of x minus f of minus x equal to 2 into the greatest integer x square by a sin x, which is equal to 0. Okay, equal to 0 implies this is greatest integer. The sin x equal to 0 implies x will be multiples of pi. So this term will not equal to 0 and 2 is not equal to 0. The only possibility is this greatest integer x square by a is equal to 0. X square by a, this is an integer which is equal to 0. Using the greatest integer property, what you get here, this is 0 less than or equal to, the function is x square by a less than 1. So take this inequality, x square is less than a. So what is the domain value? This is minus 15 to 15. Substitute x is equal to 15, you get 15 square less than a. So 225 is less than a means a is greater than 225 means a belongs to the open interval 225 comma infinity. So which is your correct answer? So B is the 225 comma infinity is the correct answer for this function. We are using the even function property and get the answer. This is the greatest and one more greatest integer and even function problem. Okay, next question. So given the function is two values, function of two variables, it's given by x, y. Then the value of the value you have to find out any of these four options. Okay, so you have to find some relation between the function. So use a distance formula for this function. What is the distance formula? Distance formula is square root of this whole square minus this. So find out some expression for the relation. So use the distance formula, square root of 2x square plus y square by 8 the whole square minus 2x square minus y square by 8 the whole square. So expand and simplify, you get this is whole square term. So this is equal to square root of this is 4x square plus y power 4 by 64 minus 4 x square y square by 8. Okay, next this term and you get minus, simplify 4x square x power 4 plus y power 4 minus, you are having minus sign, so minus, here you must get plus sign. So minus 4x square y square by 8. Okay, so cancel these two terms. This is y power by 64. Cancel these two terms. The remaining term is square root of this is 2. So you get x square plus y square by 2. Square plus y square by 2 is nothing but square root of x square y square equal to xy. So the function is nothing but your distance formula, square root of this expression whole square minus this. So this function relates to the distance formula. So using this formula you find out f 60 40, first expression f of 60 comma 48 is nothing but square root of 60 square plus 48 square. Okay, so use the calculator or you calculate by manual, you get the answer is 3600 plus 48 square. When you take square root, this answer is 36. You verify the answer, this is 36. Next f of this one, second one is 80 comma 48. Again you apply the distance formula, 80 square plus check whether you are getting this answer is 64. Okay, the last one f of 13 comma 5. Again use the square root. This is 13 square plus 5 square minus here you have to apply. Each term you have to minus you have to apply. This is the distance formula. So 13 square is 169 minus 25 is 144. So answer is just 12. So adding these three terms 36 plus 64 plus 12, you get final answer 36 plus 64 plus 12 equal to 112. Is the answer. Option C is the correct answer. The next question, we have to given the function r to r, the modulus of x minus 1, modulus of x plus 1. You have to prove it's on to or 1 to 1. Okay, first you have to prove 1 to 1 condition. Substitute, let us take a value for x equal to 1 and x equal to minus 1. Let us take and check the 1 to 1 functions. Okay, first when x is equal to 1. So when x equal to 1, so what is your value? That is f of 1, that is f of 1 is equal to 1 modulus 1 is just 1 minus 1 divided by 1 plus 1. So this is 0 by 2, this answer is 0. Next let us take when x equal to minus 1. Minus 1 again the modulus value is plus 1. So you get f of minus 1 equal to again 1 minus 1, 1 plus 1, value 0 by 2, answer is 0. So for 1 and minus 1 you are having same image. Okay, same image in the that is in the codomain. So it is 1 and minus 1 having the same images. But the 1 to 1 condition it should have distinct images. So from this two values we find out f is not 1 to 1 function. 1 to 1 function means it is many one function. Okay, so it is not 1 to 1, it is the one option. Next you have to check the on to condition. So on to condition, let us substitute in a y value. Suppose when you substitute y equal to 1. So, okay, y equal to 1, here you substitute y equal to 1 means 1 is equal to mod x minus 1 divided by mod x plus 1. So cross multiply, you get mod x plus 1 equal to mod x minus 1. So these two get cancelled, which is a false statement. 1 is not equal to minus 1. Okay, you can't take y. So for y equal to 1 there is no value exists. When y equal to 2 you take. When y equal to 2, you take 2 equal to mod x minus 1 divided by mod x plus 1, cross multiply, get 2 mod x plus 2 equal to mod x minus 1. So you get mod x, bring this mod x here, get minus 3. But modulus value is always positive. But you get in the right hand side a negative value, which is a false statement. When you take modulus value, any value, it should be positive. So since you are getting a negative value, this f is not on 2. So f is not 1 to 1 as well as it is not on 2. So what is your correct answer? This is neither 1 to 1 nor on 2. A is the correct answer for this problem. Therefore, it is not bijective. That is, it is not 1 to 1 and not on 2. So this is your answer. So next function, f from the domain 0 to 3 and the range 1 to 29. The function is given a cubic equation. You have to prove it is 1 to 1 or on 2. It's whether it is 1 to 1 or on 2, you have to prove. So we find f of x is given. So find the derivative or dash of x. Check whether it is a strictly increasing function or not. So first you check f is 1 to 1. First let us check. So find the derivative or dash of x. So find the derivative, you get 8x square minus, this is 15, okay, sorry, this is 2 into 3, 6. 6x square minus 30x plus 36, okay. So this is your derivative, you take 6 outside, you get x square minus 5x plus 6, okay. The next, when you equate to 0, you factorize the term, what you get? Factorizing, you get x minus 2 into x minus 3, okay, x minus 3. So draw the number line is the real number, this is your real number, critical points is 2 and 3, okay, and 0, this is your domain is ranges from 0 to 3, this is your domain. So by sign scheme method, you get this is plus sign, here minus sign and here plus sign. So you are having positive in this portion, that is in this portion, up to 2 to 3 it is negative, to 2 to 3 it is negative, and 0 to 2 again 0 to, this is your domain, isn't it? In this domain this is positive. So in 0 to 2 it is positive and 2 to 3 the function is negative. So this derivative of dash of x has a decreasing and increasing function. So it is not a strictly increasing or strictly decreasing function, it is a oscillating function. Therefore, the derivative is does not exist since f is not 1 to 1. If it is strictly increasing function, then f is 1 to 1, or strictly decreasing, but it is an oscillating function. Therefore, f is not 1 to 1. Okay, this is the first part. Next we prove the second part, that is f is on 2. Next we prove f is on 2. So now consider the domain values. F is from 1 to 3. Okay, first you start with f of 1. F of 1 is first value, it starts 0 to 3. So 0 to 3, f of 0 equal to, substitute f of x, first you write the f of x term, x square 2x cube minus 15x square plus 36x plus 1. Okay, so this is the value. So substitute f of 0, you substitute f of 0, you get 1. Okay, similarly when you substitute when x equal to 1, x equal to 1, you get f of 1 equal to 2 minus 15 plus 36 into 36 plus 1. So this is 15 here, 15 minus 2, this answer is 36 minus 15, this is 21, 21, this is 22, 24. Okay, similarly when you substitute when x equal to 2, check the answer, f of 2 equal to 29, and when x equal to 3, f of 3 equal to 28. Okay, so it takes all the the range values are equal to the codomain, that is 1, 24, 28, 29 are within the codomain values. So range equal to codomain. Therefore F is on 2. Okay. So what is your option? So it is B is the option on 2 but not 1 to 1. So this is your correct answer. Next question, it's given g of x is given and g of composite function is given. You have to find f of 5 by 4. Okay, so here g composite f of x is given. So first you write down what is your g of x is given by x square plus x minus 1. Now g composite of f of x is g of f of x. So in the place of x you substitute f of x, you get f of x the whole square plus f of x minus 1. Okay, so you take this is number 1. Here already you are given second equation, that is g composite f of x is this value. So write down that value. Now g composite f of x equal to 4x square minus 10x plus 5. Okay, now write down g composite of 5 by 4, that is you have to find out this 5 by 4. Just you substitute 4 into x, you substitute 25 by 16 minus 10 into 5 by 4 plus 5. Simplify, you get the answer. So when you simplify, you get 4 get cancelled, this is 4. So 25 by 4, okay, minus 50 by 4 plus 5, that is equal to minus 25 by 4 plus 5. The final answer, LCM, when you take LCM, this is 20, so minus 5 by 4. This is number 2. So equating 1 and 2, this is g composite f and this is g composite f of 5 by 4. Equating these two, you get f of 5 by 4 value. So now f of x the whole square plus f of x minus 1 equal to minus 5 by 4. So equating these two terms, you get f of x the whole square plus f of x minus 1 plus 5 by 4 equal to 0. So this is f of x is nothing but now your f of x equal to y. Already know, since this is a function which represented x and y. So you next you substitute y square plus y minus this is 1 plus 4 equal to 0. That implies y plus 1 by 2 the whole square equal to 0. That implies y equal to minus 1 by 2. So this is your answer. Which option is correct? So C is the correct answer. So C, that is y equal to minus 2 is the option C. C is the correct answer.